Good morning, chemistry students. I was wanting to continue our conversation about shapes of molecules. We have begun our conversation about Lewis structure, and we mentioned that Lewis structure helps us figure out how atoms are attached. And so we're going to move more into the three-dimensional shape. And so in class, we'll talk about this a little more, and I'll have those three-dimensional shapes for you, but we're just going to kind of get the background information down for you. So when we talk about the shape of a molecule, we have talked about the Lewis dot notation as well, and that will help us kind of move forward with this, where when we look at, say, an oxygen atom, and we look at the valence electrons and we think about how it's got two lone pairs, right? We talked about lone pairs, and we've got bonding electrons. So those things are all very, very important. And as we move forward, we'll refer to those lone pairs or those non-bonding electrons. Okay, so when we think about things, when we start talking about the shape of a molecule, we basically just have to worry about a couple of things. We have to think about how many things are attached to the atom. And I'm going to write things in quotes. Okay, and as we think about that, we want to think about the things that they can be are another atom can be attached to that atom, or there can be a lone pair attached to that atom. And those are the things, we said lone pairs were going to be super important. And so when we think about the atoms attached, right, and the lone pairs, when we think about the shape of a molecule, and we can talk about the shape around an atom, and then we can ramp that up to the molecule itself. Okay, so we're going to start small, and then we're going to build into these macronutrients as biomolecules that we've spoken about. Okay, I'm going to go ahead and start and talk about the names and the shapes. We have a reference page for this, and we're going to be specific about angles and the name of the shape. So we'll start with the very first one, and I'm actually just going to squish over here to the other page so we can write it all in one place. So the first thing we can talk about is when we have a central atom, okay, and two atoms attached to that. And what we have to worry about when we speak about this location and how atoms are set up with one another is we want to think about how negatives repel. So we talked about how electrons would repel electrons, and that kind of governs so much of what we're going to talk about today. So if we have a central atom with two atoms attached, the orientation so that these atoms can get kind of as far apart from each other as possible so that negative charge does not impact as much is 180 degrees. So 180 degrees is our angle measure, if you think about it, between the atoms around the central atom. And we call this, for lack of anything better, we call it linear, which actually makes sense because if you think about a line, the angle between points on a line would be 180 degrees. Okay, so the second situation is when we have a central atom and we have three things attached to that atom, and I'm just going to use the A for atoms. If we remember again that we're dealing with electronegativity, or we're dealing with negativity, we're dealing with these electron clouds around atoms, the way these guys can orient themselves in space is going to be sort of this planar shape. It's all in one plane, and the angle measure between them is 120 degrees. So we have three atoms attached to the central atom. The angle measure between them is 120 degrees. And the name of this shape is called trigonal, for three, trigonal. And it's planar because this is flat in the plane. Okay, so basically, again, we have this repelling going on of these atoms, and they are trying to stay as far apart from each other as possible, and that 120 degrees allows us to do that. So you have three 120 degree angles, and we call that trigonal planar. Okay, there is a subset of this. We'll just call this 2A. It's rare, but it does happen. So we have a central atom, we have a lone pair, and we have two other atoms. Okay, there's going to be a little bit of a change in the angle. It's going to get a little bit different, but we're going to just say it's close enough to 120 to call it that. So we've got this lone pair again out here that's repelling the electrons of each of these atoms right here. And so we call this This angle measure is going to be approximately 120 degrees because it's pretty close, but these electrons are actually pushing this down, so it's not exact, but it's close enough. And we're going to call this bent. That would be that's going to be the name of this. And we're going to put a caveat on that and say that it's approximately 120, and I'll explain again in a minute why. So far we've got 3 shapes. Linear, trigonal, planar, and bent 120. Okay, so our third sort of thing that we can do is we can talk about a central atom that has 4 things attached. Okay, 2 of the atoms are going to be in the plane. One's going to come out at you out of the paper, the plane of the paper, and the other one's going to go back into the plane of the paper. If you have challenges with spatial, this might be a harder conversation for you, but basically, again, we have these electron clouds that are negative that are repelling each other, and that's going to dictate the shape of this. It turns out in order to put them in the same sort of attached space, the angle measure between all of these guys, like all of them, and it's hard to do this in 3 dimensions, but we'll try. That angle measure is going to be 109.5 degrees. This has 4 atoms attached. And we're going to call this tetrahedral shape. Tetra meaning 4, hedral meaning shape. So this is a tetrahedral shape. Okay, so far so good. All right, there are 2 subsets of this. I'm going to call one 3A. We can have a central atom, a lone pair, another atom. And remember, these triangles are showing you basically the 3 dimensions, this one coming out at you and this one going back into the plane. Again, we have these electrons that repel each other, and so they still are going to push down. These electrons are actually going to push down a little bit more. This shape has 3 atoms and 1 lone pair, and its shape, unfortunately, is very close to the trigonal planar shape, but it's called trigonal pyramid, and that's because it's lifted. Let me try to spell that right. Pyramid. Okay, and again, a little bit different. These are very similar. These 2 would be very similar, this one and this one, but this one is lifted and it's got 4 things attached to it, right? So this one only has 3. So distinguishing those between each other is kind of a weird one, but we'll keep working on that. Okay, last but not least, 3B. There's still 4 things. It happens to be 2 atoms and 2 lone pairs. Okay, so we'll still draw our central atom. We have our lone pair, the one that comes out at you, and the one that goes back in the plane. Okay, and this is still approximately 109 degrees. They all are about 109.5. It's about 109.5, but not perfect because of the lone pair. And unfortunately, this one's called bent also. And so what we try to do is when we talk about the 2 bent substances, right? When we talk about the bent like this and the bent like this, we clarify that this one is about 120 and this is about 109.5. Okay, I didn't put this here, so I'm going to make sure I go back to this. This is 2 atoms and 1 lone pair. Okay, so just trying to make sense of it. This is a central atom with 2 atoms attached. This is a central atom with 3 atoms or 2 atoms and 1 lone pair. This one is a central atom with 4 atoms or 3 atoms and 1 lone pair, or 2 atoms and 2 lone pairs. So what we want you to make sure you get, okay, is, and I'll just make this a specific color. Okay, there's our linear shape. That's our first one. Trigonal planar. There's bent 120. There's tetrahedral. There's trigonal pyramid. And there's bent 109.5. So those are the shapes we want you to know. There's 1, 2, 3, 4, 5, 6 of them. So that's what we want you to have and an understanding about that. And we'll start small with small molecules, but then we'll ramp it up to bigger molecules, and each of those molecules will have the same set, the options, if you will, for shape around an atom. So just going back here, we're going to cut that off, and I'll start talking about electronegativity in the next video. Thanks so much for your attention. Have a great day.